Hello pre-calculus students, and welcome to the second part of a two-part video series on difference quotients. So we did the first page of difference quotients, which is using this formula right here in the last video, and now we're going to move on to looking at another difference quotient. Now what makes it a difference quotient is it's a quotient of differences. The other difference quotient has one difference in it as well. And this one's just the average rate of change, and it's a little bit more direct. So if we look at the original problem here and we ignore the h that you see here, ignore that x plus h, and you just have one point that's a and another point that's b, then the y's will be f of a and f of b. Then we're going to focus on these right here and just write the slope of them. And the slope would just be f of b minus f of a over b minus a. That's called the average rate of change, and that's what we have right here. Okay, so the process doesn't really require a graph, but we're going to look at the graph anyway just so we can still understand that we're still looking at the slope of the secant line. Okay, so first let me draw the secant line from the points. Now our first example is we have f of x is the cube root. This is just the parent cube root function, and we're going to find the average rate of change from 0 to 1. Now when you're given this problem in the homework, you're not going to be told that this is 0, that the y coordinates are what they are. You have to figure those out. But in this case we're told, but if you think about it, the cube root of 0, if the input is 0 here, if the input is 0, the output is 0, and if the input is 1, the output is 1. So what we're looking at is we're looking at the secant line from 0, 0 to 1, 1. And by the way, I picked this one because it's very clear that the secant line is not the same as the curve, right? It's a line, it's a secant that goes through the curve at 2 points. Actually, it goes through at a third point down here, but that's not going to really be relevant for what we're doing. And we're just looking for the slope of that line. We only need 2 points for the slope of a line, and we have them. So the average rate of change would just simply be 1 minus 0. Just put this back in black. 1 minus 0 over 1 minus 0, which is 1. And if you look at the line that's pictured, the red line, it looks like it has a slope of 1, and in fact it does. And that's all there is to it, except when we're looking at a problem, we're typically going to be given information more like this. We don't have the ordered pair. We have to find the second coordinate of the ordered pair. So in this case, what are we looking at? Now let's look at our graph. Now this is the graph of this function. It's the actual graph of this function, and notice that the scale is changed to make the graph nice and visible for what we're doing here. So we're looking at x equals 1, so this is 5 right here, so this is 1, and the point on the graph is right there. We still need to find the y value. And up to x equals 3, so 1, 2, 3, so that's going to be right up here. So now the line that we're looking for, and let's see if I can make this really show up that it's, again, cuts the curve as a secant. And so we're looking at that line right there. Okay, so that's the secant line. We want the slope of the secant line, and the average rate of change from 1 to 3. So we need the ordered pair. We need 1 f of 1, and we need 3 f of 3. Okay, so we need to find f of 1 and f of 3. So looking at the function, that's all we need to do is plug in 1. So f of 1 is 3 times 1 squared minus 2 times 1 plus 3. That's 3 plus 3 minus 2, that's 4. F of 3 is 3 times 3 squared. I should have really put this in parentheses too. Minus 2 times 3 plus another 3. And that, now this is 3 times 9, which is 27, minus 6 plus 3. That's 24. So our ordered pairs, instead of looking at them like this, we're going to look at them as 1, 4, because the output is 4, and the other ordered pair is 3, 24. Okay, I kind of lost my screen for a second, so I tried to reduplicate what we had. And so we came to the point where we know that the 2 points on the curve that we're going to find the slope of, the 2 points on the secant line that we're going to find the slope of, and this 1 f of 1 is really, now we know it's 1, 4, and this 3 f of 3, now we know that's an ordered pair. Now we know that that's really 3, 24. And the rate of change, average rate of change, will be the slope of those two. So the average rate of change would just be 24 minus 4 over 3 minus 1, which is 20 over 2, or 10. So that's the answer to part A. So part A is 10. Okay, part B is asking us to find the slope of the secant line, and the average rate of change is the same thing as the slope. So B is also, the slope is 10. That's just to make sure that you know that they're the same thing. Okay, for C, we're asked to find the equation of the secant line through these 2 points. And we already know the ordered pair of the 2 points, but now we also have the slope of the 2 points. So we're going to use point-slope form and just choose the point that has the smallest value. So we'll choose this one. So for part C, we're going to use the point 1, 4 and the slope that we just found of 10 and write an equation in point-slope form. So y minus 4 equals the slope of 10 times x minus 1. And there's our equation in point-slope form. I always prefer slope-intercept form. If it doesn't say anything there, I would just usually leave minus slope-intercept form. So this is going to be y equals 10x minus 10 plus 4. Minus 10 plus 4 is minus 6. Okay, so let's just kind of look at that and make sure that that does look like the line. So if you look at the y-intercept, you see this point right here. Since, remember, the scale, every one of these is 10, this is negative 10. So that's definitely about right for the negative 6. The slope of 10, well, the line looks like it has a slope of 1, but again, when we remember that this is a compressed scale, it's pushed way down so that the 10 is actually here, then the slope makes sense. Okay, so there's your answer. Either form is okay, and I hope you found this video helpful.